Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So in today's daily challenge on Leetcode, I will show you multiple approaches to solve the problem, starting from O of n squared to something like O of 64n and also to something like O of 32n. And so yeah, I will show you multiple ways to optimize both the time and space complexity. So definitely stay till the end of the video and subscribe to my channel if you learned something new. So let's see the problem. You need to find the smallest subarrays with the maximum bitwise OR. So I hope you have read the problem. What we need to do exactly is that at every index, we need to, let's say, iterate through the array, and every index we need to calculate the minimum possible length of the subarray which start at index and has the maximum possible OR. Okay, so what do I mean when I say OR of an array? It means that OR of all the elements within that array. Okay, so I need to find the length of the minimum size subarray. So I need to return an integer array answer of size n, where answer I is the length of the minimum sized subarray starting at I with maximum bitwise OR. Okay. So I hope you understand what do I mean by this. What does the problem means by this? So if you try to see this 10213, okay. So if I take this problem 10213, so what do I need to return in the answer? I need to return that in the first index of the answer, it will be that starting from the first index, what is the minimum possible size of the sub array such that it has the maximum bitwise OR. So you know that bitwise OR always increases in nature. So it is optimal that we choose the maximum number of elements, and it is observed that the bitwise OR of all the elements will be 3, and that 3 you can also get by OR with 1 or 0 or not ZOR. This is the symbol of ZOR. 1 or 0 or 2. If you do this, you get 3. Okay, and you took 3 length array. Okay, so you took 3 length array, so your answer will be 3. Similarly, if you start from this index, you need to take another 3 length array to get the maximum bitwise OR, which is 3. Okay, and for this you need to get only these two elements, which will again give you 3. So only 2, and for this also only 2 length is required, and for this also if you just take 3, it is the maximum bitwise OR. So the length is 1, so 3 3 2 2 1 1 2 to 1. I hope you understand that how exactly this example is happening. But one thing which you need to observe is that uh, if what is bitwise OR, okay, what is OR? If I talk of bitwise OR, you see, you have some elements, let's say this one, let's say this thing. Now let's say you have something like 0 1 0 1 0, and let's say again you have these things. Okay, so one thing is sure that I let's say I tell you that what is the OR of this, only this element, you will give me an answer. Okay, x, let's say that is x1. Now I tell you that what is the OR of these two answer, you give me another answer x2. Now I tell you what is the OR of these three numbers, you give me another answer x3. Similarly, if I tell you what is the OR of all these numbers, you give me another answer x4. So, but now I tell you what is the relation between these x1, x2, x3, x4. Uh, this is x5, right? X4 and x5. So you cannot tell the exact relation, but you can definitely tell me that x2 is greater than or equal to x1 without doing anything. Just directly you can tell me x2 is greater than equal to x1, and in general x5 will be greater than equal to x4 will be greater than equal to x3. This will always be true. I hope you understand why this is happening, because the as we add more elements in the OR, okay, what does OR means? 0 or 1 means it will give you a 1, and 0 or 0 only means it will give you a 0. Otherwise, in all the cases it will give you just 1. So that's how OR is done, right? Bitwise OR operator. That how logical OR is done. So that means that it cannot ever decrease a number. It can only remain same. If both are 0, both bits are 0, it can remain same, that is equal to, or it can increase. Okay, or it can increase. That is an increasing function, or is an increasing function. So if I tell you that what is the maximum or at the position I, what is the, let's say I tell you, you have an array, you have an array a1, a2, a3, a4. a5, and I tell you that starting at the position I, what is the maximum possible length of the, what is the maximum possible, or starting at position I and ending at some value. Okay, so you can blindly tell me that the maximum or will be nothing but or of all these elements, that is a1, a1, a2, a3, or of all the elements if I take, that will be the maximum or for this particular element. Okay, now I tell you that what is the maximum or for this element. Okay, starting with this element, so you can start with this and end as the maximum possible value, that is a5, and then that will be a3, a4, a5. So all of I mean, you can just or all of them. Okay, so what can be one possible approach to do the problem, which might give you a TLE, but it gives you some hint. Okay, so one possible approach is that you start with the, you for every position I, you calculate the maximum bitwise or. Okay, so let's say you have four elements. Let's say you have only three elements in the array. So what is the maximum? What is the or maximum or of the first element? X1, x2, x3. What is the maximum or of the second element? X2, x3. What is the maximum or of the third element? X3. Now you get a hint that you need to iterate backwards. This is because in one line, in one loop, if you want to calculate all the ors, you just have a max or value. Okay, you just have a variable max or you initialize to 0, and you just do or. So initially max or is 0. When you go through the, you are near in the last element, you just do or with x3, you get x3. Okay, and you save it in the value, then you go to this element and you or with x2 again, and you get this element and you store that here. Then again you go to backwards, you are iterating backwards, right? And you again or with another element x1, and you return the x1. So in this way you can suffix or, a suffix or you can calculate. Okay, this is nothing but you are calculating suffix or. If you try to calculate this suffix or, okay, now when you have the, that dash is nothing but the maximum or obtainable from starting from position I. That is what the maximum or of a sub array obtainable from that position I. Okay, so now you can tell me one thing, that hey, I now while iterating through the element, I have the maximum or for each position. Okay, so what I can do, I can start with this element. Okay, and I will keep iterating through next element. I will just keep iterating unless the first time I encounter a maximum or, and I will see what is the length. Let's say in three elements only I encounter my maximum or, and that is my length. So if you try to see the example here, that's also is similar. Why we get 3 here? Why we get 3 here? It's because I do 1, and then 1 or 0, 1 or 0. Then I do 1 or 0 or 2, and then I get 3, which is the maximum possible or. Which is the, I see that I used only lengths of 3, and then I save the value of 3 here. So that is how you can try to do it in a brute force manner, but that will give a TLE, right? But let's try to code that out and see if it actually gives a TLE, because it's having an O of n square solution. Because for every index, you are trying to go to the right and check that how many such values I need to take in order to get the maximum or. Okay, so for every element, if you try to go rightwards, so for every element you are iterating of the order of n, and you have n such elements, so definitely you will get an order of n square solution. But still, let's try to code it out and check what does it give. So I will do something like this, terms of dot size. Okay, and I have a vector answer with me. I will store a vector answer with me of this particular size only. Okay, and I will have a maximum or with me. I will have a maximum or with me, and I will definitely iterate from the back. I will definitely iterate from the back. Why I am iterating from the back? Because I need to update my maximum or for that particular index. So this is nothing but nums of I. So max or is the maximum or at the index I. Maximum possible or for a sub array starting at index I. Okay. So this is nothing but the max possible or for an index I. for a subarray starting at index I. Okay, I hope you get this. I hope you get this easily. Starting at index I. Okay, so you get a maximum or. Now, what can you do? You can iterate starting a j starting from I. Okay, and j less than n j plus plus. What do I mean by is you can have a length uh, of how many numbers you need minimum, how many minimum numbers you need to get this particular maximum, or so you can just do once, because one length you will need at least. Okay, and you also need to have a current or. Okay, it will give you a current or. So current or gets iterated, gets odd every time. Okay, it gets odd every time with terms of j. So I am at index I, and from that I am moving rightwards to see how many elements I can take at I can take minimum to get the maximum or. So how many elements do I take minimum? So if I see something like my current or is equal to my maximum or. If my current or is equal to my maximum or, it means that I have just finished and I can just break from the loop. Okay, otherwise I need to go to another step, I need to go to another step, and hence my length would increase by one. I hope you get this. I hope you get this pretty easily. Okay, and then what I do, I just return answer. But wait a second, I did not store this length in the answer array. Okay, so I just stored this length. And if I try to run this code, will it work? Do you think it will work? It should work, right? But it will give a TLE because this is an O of n squared solution. For every element, it is going rightward. So definitely it is an O of n squared solution. So let's just see how many test cases are passing. So you see 57 out of 59 test cases pass. So but just by doing a brute force, I'm able to pass so many test cases. So this is a fault of Leetcode, you can say. So whatever. Now I need to try to optimize this. Okay. Now listen to me very carefully. Now comes the really interesting part. How can you optimize it further? So one thing which you need to do is that you need to think bitwise. Okay, think bitwise. So what do I mean by think bitwise? You check, how do you check? So let's say you have a number A1, A2, A3. Okay, you have a number in this ways, but by bitwise, I mean that you can write these numbers in a bitwise fashion. So let's say this is a 32-bit number. So let's say initial values will be 0, and let's say last is 101. So let's say A is 5, then okay, then it will be 101. So you represent this A1 with this. Okay, and what do you do is that A2 also you represent something like this. Okay, so let's say 11101. So this is, let's say, A2. Similarly, you represent all this in the 32-bit integers. Okay, so you represent all these in the 32 bits integer and you iterate through the bits. So instead of treating this as an array, you can treat it as 32 arrays. So let's say this element, and the last element I take and create an array. Similarly, this element I will take and create another array. So this is what bitwise traversal means. Okay, bitwise traversal means that I am treating it as a separate array. Okay, and treating it as a separate array altogether, and I am using two loops. But in the process of using two loops, I will just have let's say first one will be from I equals to 1 to n. Okay, and another will be from I equals to j to 32. I will not hamper my time complexity because it is still of the order of n because of 32. Okay, this is what thinking bitwise actually means. Okay, so I hope you understand this. I hope you knew this also. What exactly does thinking bitwise means? So what do I do is that I will think bitwise, and for every index I, for every for every bit, what I will do is that I need a 1. Okay, so instead of bits can be only 0 or 1, right? So in that, in the array, I was finding the maximum element, which is for each index, I was finding the maximum OR. So I was doing OR of all the elements. But for only 0 and 1, I need to find maximum OR, which is nothing but 1. Okay, which is nothing but 1. So I need to find where 1 is occurring to my rightmost position. Okay, to my closest right position, where is the 1 occurring? So for every I, so I will have a variable, I will have an array closest of, let's say, closest of j. Okay, it will mean that for the jth bit, I need to find the closest element, okay, I to the right, which has a set bit, which has a set bit. Okay, I hope you understand this. So whichever element is having a bit set to my right, I will choose that. And here also I need to iterate from right to left. I hope you understand this. Here also I need to iterate from right to left, because let's say for the jth bit position, I am going through all the elements. Okay, so I calculate all the bits of the last element. Okay. Then the next element. Okay. So next element, let's say one particular bit is having 1. Then the closest one is nothing but that element only if it is 0. If it is 0. So the closest one is the one which in the right. Okay. Which is in the right. So that's how we do this problem. So let's try to solve this. Let's try to solve it. And while coding also, I will explain you that. So let's keep vector. Okay, not exactly closest. I will keep for a better understanding at first. I will keep something like this. I will keep something like closest of ij. Okay, so it will tell me that it will tell me something like till the ith position, starting from ith position. Okay, I will tell that for the ith position, it will tell me that for the ith position, uh, what is the what is the for the ith position, and jth bit. Okay, what is the closest rightmost position where said bit exists, means where one exists. Okay, one exists. So I hope you understand this. For the ith position, in the closest rightmost position of j, what is that with the, so let's say this is n, and this is nothing but vector of something like uh, 32. Okay, 32, and I will initialize it with -1. So what will happen if you try to see, for every bit, j, I go through all the bits, right? I go through all the bits and tell that uh, the bit is set. So I hope you already know how to check if the bit is set. If you do not know, just check this out in the bitwise manipulation. In my last video also I told you, and I've told you multiple times how to check the bit is set if bit is set. Okay. So as I told you, if the bit is set, I have my closest value is I only, right? So closest of ij is nothing but I only. So my closer, if I'm in the current index and my the jth bit is set, so what is the my rightmost bit? It is in the it's my own only. Okay. So and else I can say that else if the bit is not set, what I can do? I can simply do closest of ij equals to closest of I plus 1j. Okay, I plus 1j. But I also need to do something like if I this has to be something like if I is less than n minus 1, because this, and otherwise it would give index error I plus 1. So I hope you understand this why I did this. Okay, let me tell you that why exactly I'm doing this. I'm just copying the value. So let's say my bit is not set. If the bit is set, if my bit is set, then nothing to do. Okay, but if my, what if my bit is not set? So let's say I am treating my array, I'm looking bitwise and seeing that my array has only zeros and ones. Okay, for every possible bit position. Okay, so let's say I'm building the closest array for the jth bit, jth bit, not for the jth bit, for the ith number. Okay, you can tell me for the you can say that for jth bit. Okay, no problem with that. For the jth bit, all the elements I'm checking, and I will just tell that which is my rightmost closest index. Okay, so this index number is 0, this is 1, this is 2, this is 3, this is 4, this is just a second, this is 3 and this is 4, right? So the rightmost is 4 only. So if the bit is set, I will just copy it to be 4. If the bit is not set, what is my rightmost? It is still 4. So I will copy this element from here to here. Okay. So that is what I am doing here. So if I try to tell you what is the rightmost bit set here, it is 2 only. Okay. But what is the rightmost bit which is set here, which is in this position? Okay. So in this position only the rightmost bit is set here, which is 2. Again, for this position, the rightmost bit set is in index 2. So again, we will copy these values. So we are just copying these values in this array. We are just copying these values. For array of I am doing array of I plus 1. So that's what I'm doing, I plus 1. Okay, so I'm copying from the right. I'm copying just it from the right. And what do I do? What do I do now? Uh, I have the maximum value. Okay, I need the maximum bit. So out of all the bits, whichever will give me the maximum value. So I need to take care of all the bits, right? So for every bit, I will check what is the minimum value, which is the minimum position, minimum rightward position, which has a 1. So out of all those position, which is giving me the maximum value, that only I will choose. So I can do something like this. I can go through all the elements again, and what can I do is that I can simply iterate through all the j's. I can simply iterate through all the j's and have a maximum value, have a maximum answer. This okay, and what I will do is that I will update the maximum every time. I will update the maximum every time, which is nothing but uh, closest of I and j. So for a particular index, I am going through all the bits. I am going through all the bits and checking me that which is the maximum position, which is the maximum rightward position. Uh, See, all of these positions are minimum only. I have taken the minimum in rightmost index only. So out of all those minimum rightmost index, whichever is giving me the maximum bit, I need to obey that bit also, because I need to obey the number as a whole. So I need to obey the last bit also, because it is already told here, right? With the maximum bitwise OR. Okay. So what do I need exactly is this answer of I will be stored as maximum. Okay, and we will just return answer. So not this. Okay, we need the length. Okay, we need the length. This is giving me the index. This is giving me the index, and we need the length. So we will do this maximum minus I plus 1. Okay, so this is giving me the length. I hope you understand why I am doing this, because I hope you get it right. So from an index, let's say 2, 3, 4, if I need, let's say this index number is 1, this index number is 2. What is the length of this whole array? 2 minus 0 plus 1. Okay. So last index minus first index plus 1. I hope you get these easy things. Okay. This you can make it out on your own. So if you do not understand this, you can definitely comment and try to understand. Bitwise can be like a bit difficult at the beginning if you are new to this. Otherwise, it is a really easy thing. Okay. It is not at all difficult. It is a very easy thing. So as you see, I did not do a vector of vector here. So let's see now. So you see, we have the accepted case. If we try to submit it, So it is giving me a wrong answer. So let me just quickly check that what exactly did I do mistake here. That it is okay. So there is a small error. For every index, the maximum index is at least I, not zero. Okay, so you are starting from I and you want to check which is the rightmost index. Okay, which is the rightmost index which is having the maximum possible, or okay, which is the minimum possible rightmost index which is having the maximum possible, or so at least you will always have your particular position. Okay, so you are starting from I only, so maximum can be set to I. Okay, so that's why some error was happening. I hope you get it easily. So what is the time complexity of this code? If you try to think, you see we have an accepted thing but not a very good runtime or memory complexity. So the time complexity is nothing but 32n for this loop as well as 32n for this one. Now if you check that, nothing will happen if I just reverse this loop. Okay, if I just reverse this loop, a clever way would be that nothing will happen if I is just this. Okay, so you can possibly combine these two loops. Okay, you don't need to do it twice. You can possibly combine it in these two loops. And I want to tell you, do you need this whole vector? Do you need this whole vector? What I can do with some observation is that I can just have a single vector. Okay, so how will I do it? Uh, you check that every time I can have a maximum here itself instead of having a maximum here. I can simply have the maximum value here, and the same thing I will just copy it. Same thing I can just copy it, but I can also see that when the bit is not set, when it is set, I am telling that I is the closest value. I am currently, my position only is the closest value. When the bit is not set, I am trying to find the closest value. Okay, so then only updating the maximum makes sense. So with this little observation, what you can do, updating the maximum makes sense only in this case. Okay, so a closest is now a single array. You can just do it closest of j. Okay, so for the particular bit, for this particular bit, the closest is to my right, which is to my right. I will just take that and do this. Okay, so I hope you get it. Okay, so with this little observation, you can potentially benefit a lot. So you can remove this whole 2D array and replace it with the 1D one. So if you try to run it and check if it works, or does it have some error in it. So it is giving me some error. Closest is n. Okay, so closest is not n. I am storing for all the bits, right? So that needs to be 32. So let's try to check now. You see, we have the accepted thing, and if we try to submit it, we should get the accepted value with a better runtime. So you see, we do have the better runtime complexity. But if you want to take it to some next level, what you can do, you can update the array in place. Okay, so what I'm doing is that I'm just removing this answer, and what I'm doing is I'm just updating these nums. So you have it. You just return the nums. So if you want to take your complexities to the next level, time and space complexity, space will definitely improve, right? Should improve. So yes, you see you have a very good runtime as well as your memory complexity is like 99.57 bits. So yeah, that's all for this problem. I guess I hope you understood this. If it was your first time solving the bitwise operation, then definitely it is very normal that you will face a lot of difficulty in understanding. But it does get better with a lot of practice. Okay, you can just practice a lot of bitwise operations. So that's all for this video. If you have any doubts, definitely write me in the comment section. That will be all for my video for today. I will meet you in the next video, and I hope you have an easy day ahead. Thank you so much.